linear sequence such as this one here means that the numbers are going up or going down using a common difference, meaning going up using the same amount. So like here, from 5 to 9 means there's an increase of 4. From 9 to 13, there's an increase of 4. So basically, the common difference is a 4. Now, when we're looking for the nth term, we are saying we want a formula that works to give these numbers in the sequence. So I write 4 down because that is the common difference. From 5 to 9, 9 to 13, I just kept adding 4. So plus 4 is the same thing as just 4. Then I will put a letter N here. We tend to use the letter N for the nth term most times, but it can be any letter. Now, once we found the first part of our formula, we need the second part of the formula. Now, because over here, we kept adding 4 to get the next term in the sequence, to get the previous term before the first term here, let's put a circle in here. To get the number here, I've got to do the inverse of plus 4, which is negative 4. So we're going to say the first number, 5, take away 4, is positive 1 or just 1. So I'll put a 1 here as the 0th term. Now, that is the second part of the formula. So we write the 1 because 1 is positive, we'll put the plus here. Now, to check if this formula works, this nth term here, to check if it works, we will be substituting this n with any of the numbers we want to check for. So say I wanted to check for the third number. If I replace this n with a 3, I will have 4 times 3, which is 12. 12 add 1 is 13. So you can clearly see that the third number is actually 13. Now let's look for the first number. If I replace this n with 1, because it's the first number, 4 times 1 is 4, and then 4 add 1 is 5. You can clearly see that the first number is actually a 5. So this formula does work. Let's try one more number. So I wanted the fourth number, which is 1, 2, 3, 4. So I replace this n with 4 because I'm looking for the fourth number. Then 4n becomes 4 times 4, which is 16. 16 add 1 is 17. So you can clearly see that the fourth number was actually, or is actually 17. I'll give another example. Let's write another example so that then we can check to find the nth term as well. So say we have a number of sequences like this. Let's say we have 10, 13, 16, 19. So now the common difference here is a 3. As you can clearly see, it's going up in 3s. So I am going to write 3 as the common difference and n next to the 3. Now I need to find the other part of the formula to be able to complete my nth term. So because I kept adding 3 here to get the next number, I need to do the inverse of add 3, which is negative 3 from the first number. So 10 take away 3 is 7. Now I put the 7 here. 7 is a positive 7 in this case. So my formula is 3n plus 7. Now we want to check if this is actually correct. So say I was to look for the second number of this sequence, and I replace this n with 2. 3 times 2 is 6. 6 plus 7 is 13. And you can clearly see that the second number is actually 13. If I wanted a third number, if I do 3 times 3, 9. 9 plus 7 is 16. The third number is actually 16 here. So this is how you find the nth term of a linear sequence. Remember, linear sequence means the terms in the sequence are decreasing or increasing using a common difference, using the same number of amounts. And so this will help you to be able to find the formula that works for the linear sequence.